This brings us close to the end of our workshop. And let's start by having moderators from the breakout sessions report out to some highlights from their discussion. We have about 2 minutes per room. All right, so we have updates from these 7 tracks. I think one of them we combined in the presentation. And first up is the scaling track. Nick, do you want to talk through that?
Sure, we're sharing this session with Dave, who's going to talk about IoT next. So I'll just sort of briefly take 1 minute to summarize sort of the themes. So the overarching theme was imagining a world where federated learning has become commonplace and it's happening more and more. Then what are the roadblocks we're going to face in allowing this to happen? The first thing we highlighted was the need not only for software that allows us to explore federated learning, things like TF-Fed, but infrastructure that would allow researchers to run these softwares on realistic settings. So a large number of clients, those clients are heterogeneous, and it echoed thoughts of Planet Lab. So for those in the networking community, this was like a research infrastructure a number of years back that it did the same sort of thing for sort of internet scale sort of problems. And so it's a pairing of software plus infrastructure to investigate these problems we saw as an important roadblock for looking at things at scale. Other themes included, there's an awful lot of consideration of phones in these federated learning systems, but we saw the need to support devices even all the way down to very weak edge devices that might be experiencing a lot of interesting data that need to fully participate in those systems, and then extending all the way up into other types of ecosystems, cars and so on. They're all going to experience data. They all need to participate fully in these federated learning systems. How do we let that happen? And that led to a discussion of, can we be more flexible about the roles within federated learning systems? Could some devices that have data that are underpowered be assisted by other devices, perhaps in the same org, under the same ownership, to lend a hand with compute? Could we be more flexible about the roles? We've seen these in other distributed systems. How do we make that happen in federated learning? And finally, for a long time, people have talked about sort of fog computing and compute being in situ. So that hasn't really taken off. So perhaps federated learning could be sort of the killer motivating need to have compute inside buildings, inside coffee shops, and so on, to enable people to have their computation and other resources assisted in, allowing their services to assist people's devices to enable these federated learning systems to take off. So that was the summary.
Thank you, Nick. Next up is the IoT session.
Yeah, this segues very nicely from a lot of the things that Nick was talking about. This session was co-hosted expertly by Hubert. Thank you, Hubert. And we had interesting discussion primarily yesterday, which touched on several topics. Again, much like Nick was saying, the limited tools that are available for researchers, especially academic researchers, both software, hardware, and data, are often very limited, and being able to run large-scale experiments that are realistic is very difficult. And so there was some real interest in Flower. Nick, thank you for that talk, and it looks like a very promising system that might be helpful to many. Another big topic was a question of metrics and recognizing that different applications or different stakeholders might have different interests in the outcome metrics of a particular system. So accuracy, of course, classification accuracy is the primary metric that is often discussed in machine learning, but some might be more interested in privacy or in latency or in throughput or in system health or reliability, availability, and so forth. All of these things are important to everyone, but the question is, what's the most important? And since there are inevitably trade-offs, if you want to increase throughput, you might have to decrease latency, or you might improve accuracy at the cost of privacy, etc. And I think it's important for anyone who's designing or in particular evaluating systems to recognize and state clearly what are their success metrics and how are they trading them off. And we talked about a lot of other topics, as some of which Nick had already mentioned about edge device heterogeneity, shared devices. So the shared smartphones are the canonical model, it seems, for the participant device. And the typical model is a smartphone is a personal device, and all the data on the phone is owned or representing that person. But home devices might be shared by members of a household, and therefore might contain data from multiple people, and there may be interperson privacy issues and trust issues to be factors in. And bias might result from heterogeneity in the devices themselves, especially if that bias is correlated with kinds of factors that would be a concern with respect to the outcomes. So if, for example, more expensive smartphones are faster and therefore have a greater weight in the learning process, might skew the model towards the kinds of information that are relevant to people with more expensive smartphones, that might bias towards people who are wealthier and less towards people who are not wealthy. And that may be a form of bias that's unacceptable in certain applications. Multi-tier architectures were discussed. I'm sure we'll hear more about that in other sessions. And this, of course, security of the data is a major factor. And the question, again, about whether the data is really more secure in the data center, and is it, to what extent is it safe enough to leave the data or push the data to the edge for federated learning. So hopefully that's a useful summary, and thank you for letting me participate.
Thank you, Dave. Next up is the optimization on the data crossed out heterogeneity session.
Yeah, this is a session moderated by me and Gori. Gori, do you want to talk about it?
You can. Maybe I can talk about the first 3 points, and then you can continue.
Sure. Yeah.
So in this session, we first started talking about heterogeneity and what it means in federated learning. And then we realized that it's not just data heterogeneity, but heterogeneity of several different forms, such as computational, model heterogeneity, node participation heterogeneity. And all of these factors together affect how algorithms converge and perform. So we need to carefully characterize heterogeneity from all of these sources. And then we also need more realistic assumptions when we try to prove convergence guarantees in the presence of heterogeneity. And as a result of this session, we are also trying to come up with a list of guidelines for experiments and for theory to come up with a set of metrics that differentiate different settings, a set of hyperparameters that can be used as a uniform benchmark in future work. Zheng, you can continue this.
Yeah, we also talk about some outreach of the optimization and utility, how it interacts with some privacy, fairness, all this all together. And one thing we want to highlight is that we think we should study more about this heterogeneity in privacy research. And another thing is that we heard a lot of personalization. It sounds like a really great approach to address some of the concerns for fairness and the robustness, all that. But it is still an open question how we can train a really great personalization model that can serve as both a great initialization and a global model that can work for people without a lot of data to personalize. That's all from our session, and thank you.
Thank you, Bob.
Thank you.
And we move on to federated analytics and DP.
This was the session I shared with Jelani. So Jelani, if you're on the call, would you like to share some thoughts? I don't know.
I'm here, but I have to tend to some baby stuff. Is it okay if I leave it to you?
No worries. Yeah, I can take care of it. All right. So our session was broadly on federated analytics, and then of course differential privacy as well. So it was very interesting because at the beginning we were talking about what is federated analytics? How do you go about even defining it? We started off with a clear, concrete example of maybe we want to learn histograms or heavy hitters or count events, approximate counting, distinct elements. And then it was very clear to us that federated analytics is much broader than just computing these simple statistics. And we went back to the definition we had in the blog post that was posted on Google AI. We want to do data science type questions, SQL-like queries. So it's very broad and it has a lot of applications. The distinction between federated analytics and federated learning needs to still be carved out nicely because they may overlap a bit in certain areas, but it was very nice to list a number of applications. Stefan also talked a lot about use cases in healthcare, tracking diseases, hotspots. We saw a lot of talks from Larita, from Eva during the past 2 days talking about federated analytics. We talked about road safety and other applications of federated analytics. We also talked about how we might use differential privacy to strengthen the guarantees in all flavors of DP, local, central, and the distributed models of it. And we talked about how user-level DP is really the notion of DP that is important for this application. And Tirtha mentioned his recent work about understanding trade-offs between accuracy and user-level DP, how it's very underexplored. There are very many open questions. The role of interactivity also was discussed. Federated analytics has one characteristic that is different from simple data collection. It obviously is a superset of data collection, privacy-preserving data collection, but it has this capability of doing things interactively, so meaning that the server can maintain a state, and users participating in later rounds can do encodings that are a function of the server state. And we talked about what's known in the literature. There are some very nice recent results. Jayadev has some very interesting papers on this front, and we also all converged on the interesting conclusion that it remains largely an open and very hard open problem to understand the role of interactivity and what can it buy us in terms of improving maybe communication cost or even the accuracy order-wise or constants. We talked a lot about sketching, the use of hash functions, Bloom filters, and sketches, and why they mesh very nicely with analytics. Sketches allow you to reduce communication and computations. They bound the sensitivity of these queries that we're performing, and they mesh very well with secure aggregation because they are linear structures. And so we believe that sketching will have a great use in analytics. Next slide, please. All right, so today we started branching out a bit. We talked about things like we know how to compute some information leakage metrics for models. Things like secret sharing, membership inference attacks, so on and so forth, are very well established in the machine learning community. But what does it mean to quantify information leakage from a sketch or from a Bloom filter? How do we come up with these quantities to measure overfitting to a particular user? These are all mostly absent. We were able to identify maybe 1 or 2 papers today, but we still believe there's a lot of work that needs to be done. We also talked about attacks and robustness. What does it mean to insert a backdoor in terms of heavy hitters learning or counting? Or how do we go about defining this in the federated analytics? We talked about fairness and tension between fairness and robustness. So there's just a lot to be explored in this area. And if you're interested, please reach out.
Thank you. Next up is optimization theory.
All right, so I'm Suhas Degavi, and I was co-moderating this with Zachary Garrett, and by the flip of the coin, I get to say some things in the 2 minutes we have. So clearly, optimization theory encompasses many of the other breakout sessions, and therefore, clearly there is going to be overlap with some of the bullet points that we talked about with other breakout sessions as well. So there was a discussion on various topics. The first one was really on what are the optimization challenges in the federated setup. In particular, how does heterogeneity in both data and other aspects affect convergence and performance? But I think the interesting specific question that came out, which I think may be useful to think about, and was we touched upon with Chuan and Zach Charles, is essentially how to do variance reduction methods in a local and global regime without state. And Sashag pointed out some interesting work that they have done in follow-up with Scaffold, and this is something that is worth exploring. Another point that we discussed is at the very end was thinking about lower bounds. A lot of these are really, there have been lower bounds established for first order oracles for a generic setup, but not in the federated learning or optimization setup. So how to develop these right lower bounds in these with these characteristics in mind is something which is worth exploring. The second, I'm going to skip to the last bullet because sort of thematically, we talked about compression in federated optimization, and we talked about two kinds of compression. One in terms of gradient compression, and there's been a lot of work in gradient compression in the last few years. How does it apply to the federated setup, especially converting stateful methods to stateless methods? But we spent a lot of time also in another aspect of compression, which is model compression. So there is a sort of tension between ideas where you're increasing model sizes all the time, and clients cannot possibly store these models as large models as it grows to tens and hundreds of millions of parameters potentially. And so how do we do this? There are two issues. One in the training period, where you can, of course, split up aspects of which parts of the model each client contributes to. But in the inference time, you really need to develop the right models that need to be stored. And how do you do that? And that's another question that we came up with. In terms, skipping to the same theme of personalization and meta learning, we had a discussion of really saying there's been a lot of suggestions in different optimization frameworks, different optimization criteria that have been suggested for this. And it's like comparing apples and oranges. Each of them has different objectives. What is the right overall structure? What is the overall question that we are trying to answer? How do you pose this and ask the optimization problems to be essentially regimes of what you want to achieve, rather than sort of piecemeal different optimization problems? And that's really what came out of that discussion. In terms of differential privacy, one of the things that came out was essentially how do you work with different optimization landscape? In particular, what kind of clipping strategies? How do you adjust those to what is required for optimization versus what is required for differential privacy? For example, certain strategies can give very poor convergence, and so you don't want to do that for optimization, whereas that you might be thinking of doing that for privacy reasons. And the last point was really on robust optimization, Byzantine resilient optimization. Now, there's been a lot of work which has been done recently in how to do sophisticated adversary filtering, especially in high-dimensional spaces. But all of these are not compatible with secure aggregation. So in other words, how do you actually combine many of these much more powerful methods for Byzantine resilient optimization with a framework which is on secure aggregation? So these were a subset of, there were many other things we talked about, but we sort of converged on just presenting these.
Thank you, Suhas. And next we have the differential privacy and secure computation sessions.
Hello. So yesterday we spent the whole session actually talking about this magic box that is currently secure aggregation that will compute a function for you in a way that leaks nothing but the output of the function. And going back to what Suhas was saying, if making that function be vector summation imposes some restrictions on what you can do in that architecture, right? So that's exactly the discussion that we had yesterday. Is secure aggregation the right function? Does it impose too many restrictions? In particular, given the known results for privacy amplification in the shuffle model, we know that shuffling can give you some advantage, but is shuffling and secure aggregation essentially the same thing? So we ended up discussing this complex landscape with like at least 4 dimensions in terms of trade-offs, and trying to identify what are in the context of differential privacy, what are interesting or useful primitives that we may want to implement in secure computation to enhance secure aggregation in a way that allows us to obtain maybe more accuracy or better amplification, right? So primitives that came up were essentially targeted to be able to implement in the federated learning setting non-trivial mechanisms like that include or involve some kind of nonlinearity, like, for example, the exponential mechanism, which is very useful, or the sparse vector technique. All these kind of techniques, the moment you are limited to shuffling or secure aggregation as the task that is performed in this magic box, are thrown out the window in Abradip's words. So that was yesterday, and today we switch gears. So I'll let Kamalika present the second day, and then contradict me in anything that I said. If she please.
So today we talked about the second part of the session was supposed to be about different notions of privacy other than differential privacy. I mean, we are doing federated learning, but differential privacy may not be exactly the right notion that we are looking at, right? I mean, not be exactly the right notion for every application. So what are some other alternatives? And privacy notions are generally very application dependent. So for example, if you're building a language model, the notion of privacy that you would use may not be the same as if you are building a classifier out of medical data. So we talked about some plausible applications. So one of the applications that came up is information sharing across companies, where differential privacy is not always sufficient because companies are, for example, trying to protect trade secrets, right? So they may have, an example that was given was, they may have malware applications or cybersecurity, where if there's a new class of attack that is emerging, which a lot of companies are seeing, if you analyze their data together, you may be able to detect it. So that's, something that you want to do, but the companies don't want to share all their data because they may not be able to, they may not want to share all their data because trade secrets may be revealed, right? So one plausible thing we discussed was, one possible solution to this kind of thing might be secure multi-party computation. Another aspect is, but one challenge that came up was scalability, and it wasn't clear if it might meet the demands of for some applications, but not others. Other aspects where, so for example, in a lot of financial institutions, you need model privacy, not just user privacy. And so there's a bit of unease about how one can do that. And so basically in this area, there are lots of open questions.
Thank you. Security and robustness.
Hi, I'm Pratik. I had the pleasure of co-moderating this session with Daniel Ramage, a fantastic set of participants. In our discussions, we were struck by the tremendous heterogeneity that exists at the intersection of robustness and federated learning in terms of the different types of trust models that are possible, the different types of capabilities that adversaries might have, and their corresponding objectives and attack algorithms. So for example, think about the difference between a nation-state level adversary trying to disrupt a federated learning ecosystem versus an adversary that merely compromises a handful of user devices. Similarly, think about the difference in trust models that might exist in terms of a cross-device scenario of hundreds of millions of devices versus the cross-organization scenario that Kamalika was just talking about, where you might have a handful of 20 to 30 trusted participants. Similarly, think about the capabilities of an adversary who might be able to overwrite an application logic on a device to do model poisoning attacks versus an adversary that merely supplies poisoned data to a benign federated learning device. So it turns out, across all of these different scenarios, the research community has made tremendous progress and showed that many attacks on robustness are feasible, both from an untargeted perspective, where the entire model is being corrupted, and from a targeted perspective, where the adversary has some very strategic objectives. I think one interesting point that came up was that in some ways, attacking the tail is easier than attacking the head. And I'm using the word tail to refer to points that are less likely to generalize anyway. But it's certainly very important to care about this tail, as was shown by both the keynote talks in this workshop. But I think this wide heterogeneity really inspires a call to action for us as a community, because we are in need of some strong benchmark problems in which some realistic scenarios are incorporated, tied to this notion of what is the robustness that actually matters in practice. For example, robustness that can capture some notion of an adversary's incentive in terms of fraud, in terms of abuse against some target groups. And these types of benchmark problems in realistic scenarios must consider the practical constraints that are imposed on the adversary in realistic industry deployment. So for example, thinking about the scale of Google's deployment, it's not feasible to consider an adversary that's compromising 10% of the devices. Similarly, real deployments may have some mechanisms for admission control against civil attacks. They may have some mechanisms for abuse detection that might enforce some quality control against attacks of robustness. We talked about a lot of open challenges in this space, too many to articulate. I think one recurring theme was that many of the existing defense mechanisms can be bypassed by adaptive adversaries that can incorporate the defense mechanism in their own loss function. And this really motivates the development of defense mechanisms with some notion of provable properties, or some notion of a certified robustness. And this is really, of course, hard. And existing defense mechanisms with some provable properties are very, very sparse. It's probably easier to come up with some of these mechanisms in the domain of untargeted attacks, but it seems much harder to do this for targeted attacks. And I think the final point that came up was that as we're thinking about the development of these defense mechanisms, it's very important to keep in mind the trade-offs that might arise when these mechanisms are combined with other technologies, for example, privacy techniques like secure aggregation, like differential privacy. I think that's my time. Thanks.
Thank you, Pratik. Was that the last breakout? Did we forget anybody? Did I skip anybody?
We did not.
We got all. Great. That brings us to the end of this workshop, but don't forget, tomorrow we will still have TensorFlow Federated tutorials. And I have to say, it's been quite a journey. We initially planned this as an in-person workshop, as you know, and then at some point, a realization dawned on us that that might not happen. And we got to the point where we even questioned whether we could hold an effective workshop at all, and whether we should just be canceling this, since it seemed hard to get a productive workshop-style discussion going in a virtual format. But I do have to say, I'm so encouraged and so excited how you all have responded to this workshop, the participation that we've seen, the discussions that we've seen in this workshop. And I hear there's even talk of writing a more formal report or papers again. Thank you so much. Peter, do you want to say something about the paper?
Yeah, so some people in their breakout sessions talked about writing a collective paper on the topic, maybe merging or combining these efforts. So if that's something you're interested in, please drop your name in the breakout session, and then breakout session moderators can perhaps reach out to discuss the possibility if there's enough cycles and bandwidth. I want to thank everybody. As Marco said, this at one point seemed impossible, and I'm so happy to see you all engaged, participating, and hopefully you've enjoyed this workshop. And thanks to all speakers and all participants.
Yeah, I also want to say, you see Peter's and my name up here, but this has really been a team production. There's a federated learning team here on whose work we are building, and there's a number of people I think we should specifically call out. First, Seng and Adria have been helping us a lot in putting this workshop together. And there's Jennifer Yee and Rania Aliman that have been sort of staying in the background of all this. They're from our university relations team and have really been keeping us on track and doing much of the heavy lifting with the organization of this workshop. And last but not least, Brendan McMahon and Dan Ramage are the ones who inspired us to actually put this workshop together. So thank you all, and I do hope we'll be able to see you in person again at sometime in the not too distant future.
Thank you.
Thank you.
All right.
Thank you.
Bye.
Thank you.
Bye.
Thanks, you guys. It was a wonderful workshop.
Thanks, Rachel.